Summer Physics 1-2, we're moving on to our next lesson, day 12, on momentum. So what is momentum? Momentum is the part of Newton's first law that deals with motion. An object that is already in motion wants to stay in motion. So what is the formula for momentum? Momentum is equal to an object's mass times its velocity. The abbreviation for momentum is small p. We write the formula for momentum as P equals mvi. That's mass times instantaneous velocity. In some books, they write the formula as P equals mv, but you need to be sure to use instantaneous velocity, not average velocity, to compute it. So what are the units of measure for momentum? The units of measure for momentum is, well, mass is measured in kilograms and velocity is measured in meters per second. So this is simply read kilogram meters per second. So let's take an example. A 10 kilogram bowling ball rolls at a constant velocity of 2 meters per second. First of all, what is its momentum? And then second, what is its force? So momentum, we simply apply the formula, P equals question mark, m equals 10 kilograms, instantaneous velocity is 2 meters per second. Now if it's got a constant velocity of 2 meters per second, that could be its average velocity as well, but it's also its velocity at any moment in time. So we're going to say that's instantaneous velocity. So P equals mvi, you plug in the numbers 10 times 2 and you get 20 kilogram meters per second. Now, interestingly, what is the force? There is no force because the ball is moving at a constant velocity. Remember, force equals mass times acceleration. If it's not accelerating, then there is no force. So that might seem strange that this object, kind of a heavy object, is rolling along and doesn't have any force. We're going to address that in just a minute. So compare these two equations and remember the difference, that force equals mass times acceleration and that momentum is mass times the instantaneous velocity. So imagine a big heavy asteroid is flying through space. When an asteroid is traveling through space at constant velocity, it has momentum because it has mass and it has velocity, but it has no force because there's no acceleration. So when does it have force? We know that that's going to have force at some point. Well, once that asteroid strikes a planet, hopefully not the Earth, the sudden negative acceleration slowing down, in other words going from very high speed to no speed, is going to create the force. So that's where the acceleration comes in. It only has force when it strikes something, but it's not said to have any force when it's just flying freely through space. So pulse. A pulse is kind of the opposite side of force. It's almost, or opposite side of momentum rather. It's what it takes to stop a momentum. So a pulse is force times the amount of time applied. So it's force times time. The units of measurement for a pulse are the same as momentum. So that means that a pulse can oppose a momentum. So pulse is also called impulse. So the amount of pulse needed to stop an object's momentum is always constant. So if you take the momentum mvi and you equate that to the force times the time, that's the amount of pulse that it will take, or impulse, to stop a certain amount of momentum. So how much force would it take to stop a car with a momentum of 15,000 kilogram meters per second in 10 seconds? So here the time matters. So force equals question mark, and you know the momentum, it's mvi equals 15,000 kilogram meters per second. And the time is 10 seconds. So you're going to use that formula. Force times time equals the momentum, or equals m times vi. So we just plug in the numbers. We're going to solve the equation for F, because you want to solve for F. You want to know the force. So you simply divide both sides by T, as you can see there. And so you have force equals mv, should be mvi, over T. Now you come back and plug in the numbers. So force is 15,000 kilogram meters per second divided by 10 seconds. So the force would be 1,500 newtons of force would be needed. So if that car is moving with a momentum of 15,000 kilogram meters per second, you would have to apply 1,500 newtons of force for 10 seconds to bring that car to a stop. So, a soccer player shoots the ball at the goal with 15 kilograms meters per second of momentum. All right, so that's the mass of the ball times the velocity that it was kicked. So here's case number one. The goalie can punch the ball away by using a lot of force for a short amount of time. So the momentum is 15 kilogram meters per second. So let's say he punches it with 150 newtons of force, but for a very short amount of time. 0.1 seconds. In other words, that ball is in contact with his fist for only 1/10 of a second. Then to change that momentum or stop that momentum, he's going to have to apply 150 newtons of force. But what if he doesn't want to punch the ball away? What if he wants to catch it? Then the goalie can catch the ball by letting the ball hit his body or his hands softly. He does this by using a small amount of force so the ball won't bounce off his hands, but it spreads it out over a longer amount of time. So in this case, he's going to catch the ball. It's going to take him 1 second to bring the ball to a stop instead of just 1/10 of a second. Therefore, he only needs 15 newtons of force. That's a much lower force that his hands are putting on the ball. So therefore, the ball is going to kind of just sink into his hands and he'll be able to catch it rather than have the ball bounce off of his hands. All right, and that takes care of this lesson on momentum.